So far, we've resized and cropped images. In this lesson, we'll learn how to rotate them. Image rotation is a common task in computer vision because photos aren't always perfectly aligned. A document might be scanned at an angle, a camera might be tilted, or an object might simply appear rotated in the image. OpenCV provides two ways to rotate images. For simple rotations of 90, 180, or 270 degrees, we can use CV2.rotate. It's fast, easy to read, and perfect for most situations. Let's rotate our image 90 degrees clockwise and display the result next to the original. But what if we want to rotate an image by 30 or 45 degrees? For that, OpenCV uses something called a rotation matrix. Don't worry about the math behind it yet. Think of it as a set of instructions that tells OpenCV how every pixel should move during the rotation. To create this matrix, we'll use CV2.getRotation matrix 2D. We need to provide three values: the center point of the image, the rotation angle, and a scale factor. A scale of 1 keeps the image at its original size. Next, we'll apply that matrix using cv2.warp-affine. This function creates a new rotated image based on the transformation we defined. Notice what happens after rotating by 45 degrees. Some corners of the image are cut off because the rotated image no longer fits perfectly inside the original frame. This is completely normal, and later in the course, we'll learn techniques to avoid clipping when rotating images. Image rotation is widely used before running OCR, face detection, and mini machine learning models. Correcting an image's orientation often leads to much better results because the algorithms receive data in the format they expect. Try experimenting with different angles such as 15, 45, or 90 degrees and observe how the image changes. Small experiments like these are the best way to become comfortable with OpenCV's transformation functions. In the next lesson, we'll look at another useful transformation: flipping images horizontally and vertically. It's a simple operation that's commonly used for image augmentation and preparing training data for AI models.